Okay guys, this is the introduction to set theory. If we took these chords up on the board here, you took these three chords and you say, well, this is a C, G, E, C, E, C, G, C, G, E, C, G. You would say in your mind, what chord is this? It's a C chord, because you would be compacting it in your mind to a CEG. Even though it doesn't say CEG, in your mind you are saying CEG, and you see that it's been manipulated and it's been voiced in an open position like that. And in the same way, even though you have E on the bottom, you would do this chord the same way. In your mind you would say, well, it's a CEG chord with an E in the bass, but ultimately it's a variation of just a regular CEG. We would call it a first inversion, but you would be able to see those notes and recognize it as a variation of this very basic triad, and you would be able to do the same thing here. Even though there's a G in the bass, it's G, E, C, G, you would be able to say that it's basically a CEG that's been inverted and spaced in a certain way, but your mind would recognize these three chords as basically the same chord in just various manifestations. And this chord here, you would do the same thing, except you would say, well, this is a D F sharp A. It's a D chord. It's basically D F sharp A that's been voiced differently in an open spacing. And here you would say it's a first inversion of that. And here you would say it's a second inversion of that. But then you could collapse it down in your mind because you know this is where it came from. In tonal harmony, we're able to do that very easily because we're accustomed to these major triads and minor triads and so forth, and we can recognize them in various ways. The problem comes in atonal theory, and by the way, you would recognize this as related to this by transposition. So you would say, well, this is basically the same material as this, transposed up two semitones, and you would see the correlation. They're both major triads starting on different notes, and so you would be able to, for example, look at this chord with an A in the bass and this chord with a C in the bass and know immediately that they are related in some way. They are transpositions of one another and inverted. So they've been taken and manipulated, but basically they come from the same quality, they come from the same stuff. In atonal music, though, it's a little harder to do these things because we're not dealing with known chords. Let's say we had this chord, C, B flat, F sharp, and D flat. And let's say we transposed that up a fourth so that we'd have F, E flat, B, and G flat. And then let's say we inverted this chord and we bring the G flat down, the E flat down, and so we go E flat, B, G flat, and then bring that F up there. Would we be able to see this relationship that we've taken this chord, we've transposed it a fourth, and then we inverted that transposition? Would we be able to take these four notes and see in an atonal composition that they are related to these four notes? Well, we probably wouldn't even notice it because these are not major chords or minor chords. They're just collections of pitches with no qualities from what we are used to. But what set theory does, it allows us to see this chord as related to this chord because it puts them into a different kind of grouping other than major, minor, diminished, and augmented. It puts them into a different kind of grouping. So set theory is basically the idea of how to recognize when something is related to something else in a harmonic way, in the same way that we can do it here. But here we have chords. Here we don't necessarily have known chords. It's a methodology to allow us to see similarities between groups of notes, that this is basically the same as that. just transposed and manipulated in some way. So let's dig in the next video to actually how we're going to do that. What is set